Find the indefinite integral. Use arc notation. Do not raise to the negative 1 power. Now, I'll mention this. It actually doesn't make any difference if you use arc notation or raising to the negative 1 power any longer. It used to be that the system wouldn't allow something to the negative 1 power. It does now, so this is kind of old, but that's okay. It's also a hint that we're using arc trig functions in order to evaluate this. And really, I don't need this plus c written in here. That's just where the answer blank is in the question. Now, since we are doing an arc trig function, and if you didn't know that already, then just know that you've got a square root in the denominator. It's the square root of something that looks like a circle, where you have a constant minus a square function. And there's nothing in the numerator. So, well, there is technically. It's a multiplier of 1, but it's definitely not the derivative of the denominator. So if it was, we could use the logarithmic rule, but without that, we need to use arc trig functions. So we need to decide which one we're going to use. And it's really just, you have these memorized and you decide which one fits best. So square root in the denominator, that means either arcsine or arcsecant, so tangents out. There's no multiplier on the outside of this, so that means arcsecant's out, and we're just working with arcsine this time. All right, now let's identify the constant a. So this term is a squared, so the square root of 49 is going to be a. Then it's minus u squared, so u is the square root of x squared, which is just x. And it's important to note this because we also have to make sure du matches up. So du here is just dx, which is what's in the numerator, which is what's noted over here. So that's great, we're done. All we need to do to integrate this now is to just follow the formula. The formula says this is arcsine of u, which is x, divided by a, which is 7, and plus a constant. Now we're all set.